hypothesis testing using a one-sample t-test. Now, imagine that we had this data where we had the weight of various babies that were born in our hospital. And we looked at our data, our sample of data, and we wanted to test to find, is the average weight of infants born in our hospital less than 3,100 grams? Well, what I need to do is a full 7-step hypothesis testing procedure. And in this case, what I do is I start with the alternative hypothesis. I start with what your book calls step 2. So in this case, what I'm asking is if the mean is less than 3,100 grams. So that's what I write down. And then I move on to step 1 after doing step 2. For step 1, I do the HO, the null hypothesis. In this case, it's got to cover all the bases, every possibility other than what I've already covered in step 2. So if our mean is not less than 3,100 grams, then it must be either greater than 3,100 grams or it must be equal to 3,100 grams. So our null hypothesis states every possibility except for those covered by our step 2, which is our alternative or our research hypothesis. So now I'll move on to step 3. Step 3, we just state what our alpha is. Now we typically use an alpha level of 0.05, and that's what we'll use here. In this course, use 0.05 unless specifically told to use some other alpha level, which in rare case might be 0.01. And there is some times where people use 0.10, but only when finding significant effect works against their doing something. Well, almost that's the only case. So here we're going to use an alpha of 0.05, which is pretty typical. Step number 4, we need to find the rejection region. Now before we find the rejection region, let's look at our situation here. What we're asking is if the mean of the data is less than 3,100 grams. So I'll draw a normal curve. We have to assume a normal curve in this case. We put the mean of, we've got an alpha of 0.05. And now normally what we do is we do a two-tail test. And normally what we want to do is we take half of the alpha and we put it on each side of the curve. So we put half in the left tail and half in the right tail. But in this case, we want to do a one-tail test. So in this case, we're only going to reject if we get a t-score less than some negative t, because we've got 3,100 grams, and what we're trying to do is demonstrate or find if our infants are significantly less than 3,100. So that would be on the lower side, or in the lower tail. So we need to put an entire 0.05 in the lower tail. Now whenever you do, whenever you're trying to find the rejection region, and you're doing a t-test, you first need to find degrees of freedom. And the degrees of freedom is the number of scores minus the number of groups. Now this, by the way, degrees of freedom are calculated differently for different types of statistical tests. So you can't learn one rule for degrees of freedom and apply it to everything. In this case, for t-test, it's the number of scores minus the number of groups. In our case, we only have one group of infants. And if I count right, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 scores. So we have 10 scores minus, because we have one group, that gives us 9 degrees of freedom. So our degrees of freedom are 9. Now one other thing that I need to explain to you before we can have Excel calculate this for us is Excel assumes that we're using a two-tailed test. So it's going to take our alpha and divide it to 2 and put half in each tail. So if we want to put our entire alpha in one tail, what we really have to do is kind of trick XL. What we need to do is double what we tell XL our alpha is, so when it cuts it in half, it'll put the entire alpha in each of the 2 tails, and then we'll just look at one of those tails. So in our case, our alpha is 0.05. So we're going to tell XL that our alpha is 0.10, which is twice 0.05. And then it's going to divide it in half and put 0.05 in each tail, which is what we want. We want 0.05. And then it'll give us a t-test, and we'll know it needs to be negative. And we'll make it negative and put it on the left side. So how do we do that? Well, the first thing I'm going to do is I'm going to go down to cell A13. I just picked an cell. And I'll put T crit, meaning this is where my T critical value will be. Now I'll go over to B13, and I'll type in an equal sign, then T INV, stands for T invert. Normally, when you're doing your T, you give it values and you try and find out what its probability is. This is the inverse of this. We're going to give it a probability to find out what the T score is. So in this case, I put equal sign, TINV, then left parenthesis, and now I don't tell it where the data are. Instead, I first tell it the alpha probability, which we're going to trick it to say it's 0.1, and then I put a comma, and then I have to tell it the degrees of freedom. In this case, we have 9 degrees of freedom. Then I'll close the parenthesis, and then when I hit enter, I will get 1.833114. So this is what I'll put in my rejection rule. So here's the picture where I've added in the value that we got from XL. So now I know that if I'm going to get a T score which is less than negative 1.8331, I can reject the HO. But if I get a T score that's greater than a negative 1.8331, I'm going to have to fail to reject the HO. So let's put this in our rule. Here we are. Here's our rule. I'll say reject HO if the T comp is less than negative 1.8331. So now what's left to do is to calculate our T comp.